Alright, so what we're going to get into is basically asymptotes of rational functions, how to graph one of these, and basically what that means is we want a specific vertical asymptote. For our example, most likely just one. Same thing with a horizontal asymptote. We're going to put those onto a graph, and then we're going to kind of figure out where does our line go within each of those. So to get started here, if you think back to a more simple version of a rational function, what you look for is x plus or minus some number, and that helps us determine which way we shift our graph. For here we don't have that though, so what we need to do to where it kind of looks like that is take the denominator and we're going to factor that. So what we need to do is take this and factor it. So we're going to think maybe quadratic formula. Product sum's probably easier, but remember that doesn't always work. And what you'll end up with when you go through that is a new denominator that looks like x minus 2 squared. You'll actually end up with that over itself twice. What that basically means is that we're going to have a shift to the right by 2. And even though we have that twice, basically we have two asymptotes on top of each other. It doesn't affect how the graph looks at all. So we're going to have that up here at 2. So I like to put a dotted line just to show that that's kind of a barrier, like an invisible wall that your line's never going to go through. So that tells me that my vertical asymptote, the one that's straight up and down, is at x equals 2. I think that that's the easier of the two parts, but once you kind of get horizontal under your belt, it's not that much more difficult, I'd say. It's maybe just a little bit lengthier until you get the process down, and then maybe even shorter. So what we're going to do to find a horizontal asymptote is what we're going to try to find the x value that carries the largest exponent. So almost like the degree of the entire function, which here is a 2 because we have x squared and an x squared. Basically we have a quadratic on top and a quadratic on bottom. So what that leads us to doing is divide the entire thing by that. So we're going to divide the entire thing, all 6 of these individual terms, by x squared. So what that's going to leave us with is, once we divide this, we're going to have just 3. Once we divide the first term on bottom, we're going to have just 1. Both of these middle terms only start with a single x, so they're going to be over x once we divide. So minus 12 over x, minus 4 over x. And then the last term in each doesn't start with an x at all, so we're going to have x squared on bottom once we divide. So 13 over x squared, 4 over x squared. So after we simplify all of that, after we divide by x squared through all 6 of those individual terms, we need to think about what's really happening is we're trying to test for when we have really big x values and really small x values. So really far negative, really far positive. So essentially what we're doing is we're plugging in infinity in for x. So if we take any relatively small number like 12 or 4 or even 13 and divide it by infinity, biggest number you can think of, it's going to get so close to 0, 12 divided by however many numbers you can type in on your calculator, it's going to be really close to 0, so much that we're going to just count it as 0. So this is going to be basically 0, basically 0, basically 0, basically 0. So all that's left are the first terms, 3 over 1, or just 3. That's where we're going to put our horizontal asymptote. So 1, 2, 3. That's where we go from there. After that, we need to think about the lines themselves. So that's where we're going to have to make a table. So now that we know our vertical asymptotes at 2, I can fill these in. And what each of these means is it's as x approaches 2 from the left, So as we look at values that get closer and closer to this asymptote from this side, and then the one on the right down there that has a plus symbol, an addition symbol, it's basically saying as we approach 2 from the right, from bigger values. So let's test. So we need numbers smaller than 2. Let's go 1, 1.5, and 1.9. And then on the other side, let's go with, we need bigger than 2 going down. So we need 3. Let's go 2.5 and 2.1. Try to keep it similar. From here, all I'm doing is I'm going to plug in a couple values to see what happens there. So I'm going to plug in 1, 1.5, 1.9, 3, 2.5, 2.1 in, and we're going to see what we get. I'm actually going to go through and plug those in now, so you can do this with me if you want to follow along and make sure I'm getting the right thing too. So if I plug in 1 on top here, we get 4 divided by, we get, this is equal to this, so I might just plug into here. So if I plug in 1 minus 2 squared, well, that makes sense. 1 minus 2 is negative 1, squared is just 1, 4 divided by 1 is 4. So that's my first one. And let's do 1.5 now. So I got 3 times 1.5 squared minus 12 times 1.5 plus 13. So on top I get 1.75. That whole thing divided by if I plug in 1.5 here, I'll have 1.5 minus 2 squared. This is going to give me 7, and then let me try it again with 1.9. Now that I have it in here, it's going to go a little bit quicker. And we notice it's going to jump up to 103. Let's do the same thing with these numbers approaching from the right. So I'm going to try just 3 right off the bat. It's going to give me 4 as well. Let's try 2.5. And I'm wondering if we're going to get the same thing as the other side over there. I get 7 again. Well, that makes me feel a little bit better that I'm probably doing it correctly. That means that on both sides of the asymptote we're going to end up with something pretty similar. And even with this last one where it makes a big jump, it's going to go to 103. And I would venture to tell you that if we kept plugging in numbers that were closer, like 1.99 or 2.01, this number for the Y column would be even bigger. So what do we do with that information? Basically, as we get closer to 2 from both sides, the numbers jump up really high. So I'm going to end up with something like that on both sides. Remember, they're never going to actually touch that asymptote. But basically at 2.1, it's going to be 103. I can't reach that high up there, so the reason I put the arrow is that obviously I'm like 5'10" on a good day. So I got to stop right there. We already found the horizontal asymptote, so this next part's a lot easier. It stops at 3, so we know that it's going to curve down and hug the asymptote. Same thing over here. We're not going to end up with any values on bottom, so we're going to end up with a domain that's everything except 2. It's the only x value we can't have. And a range that's all y values bigger than 3. So that's what we're going to get for a rational function that includes domain and range. You got to see where I picked specific values from, and they don't have to be those numbers. I just picked things that got closer to 2 from both sides, so I just wanted to show you how that process works. If you got questions, let me know in the comments. Hopefully it helped.